Hello, this is Mr. Collier, and today we're doing financial applications. Okay, so we're going to look at compound interest, and as you can see, compound interest grows a lot more than simple interest, and it's used more commonly in real life. Here is the formula, a screenshot from the formula booklet, and it's the compound interest formula. Let's take a look at the formula booklet. So you can see it defines the variables right there. Present value, n is number of years, k is number of compounding periods. So what that means is, often in real life this k is 12. The interest is compounded every month, and there's 12 months in a year, so k equals 12. So what they do is take the interest rate and divide it by k, and they use that interest rate for 1 month. Okay, so if you get a 20% credit card, what you get is you get 20 divided by 12, and whatever that amount is your percent for 1 month. So it actually doesn't work out to be 20% per year. It works out to be a little bit more. Okay, so the 100 in the denominator is just to change the percent to a decimal, and k is the number of compounded periods, n is the number of years, so it's easy to use the formula. If it's compounded annually, in other words, it's not compounded monthly or anything, any weird wording like that, then it's just this formula right here because k equals 1. So let's look at an example. Peter invests $2,000 in a bank that offers simple interest. Well, let's not do this one. This is simple interest. Let's do this one over here. Meryl and Christy each have $5,000 to invest. Meryl invests her money in a bank that pays 4%, 4.5% simple interest per year, and 4.4 compound per year. Okay, so we can actually, one is simple interest, one's compound interest, so we can do both of those. So let's take a look at the simple interest first. 4.5% per year would be, now the amount would be, let's use FV for future value to be consistent. This is actually what's used, future value, two-letter variable. The future value for simple interest would be the amount plus the interest. So that's the amount times the interest rate times the number of years, which is 15. Okay, so we're going to calculate that in a second. And future value for compound interest, we can use the formula from the formula booklet. 5,000 times 1 plus 4.4 over 100 is compounded annually, so that's just k equals 1, or you can just ignore it because it's 1. Okay, so let's work those out. This should be 4. Oh, this is 4.4. Yes, it's a little bit less. I think we'll see that compound interest earns you more money. So we got 5,000. Oops, 5,000 plus 5,000 times 0.045 times 15. Gives you 8,375. Okay, let's check out the other one. With compound interest, we get 1 plus, you can make a fraction, 4.4 divided by 100, and to the power of 15. So you get 9,538.44. Okay, so let's take a look at when we have something compounded more than one time during the year. So quarterly, let's check out quarterly. Quarterly means 4 times a year, so k equals 4. Okay, so let's calculate how much money she has after 6 years. So future value equals present value times 1 plus 3 over 100, and this is k equals 4, and we'll do to the power of 6, right? In the second one, we're going to be calculating how long it takes to double. So I know I'm going to be typing that into my functions app. So I'm going to go and do part A and B in the functions app. So we can do 80,000. 1 plus fraction. Now I think I made a bit of a typo over here because I forgot to put the k in the numerator. Look, it's going to be is k times n in the numerator. So number of years is 6, and the number of compounding periods is 4. Okay, so you can put a 6 times 4 up there, or I could just put a 24. Actually, I'm doing this in the function app, so I'm going to do actually 4x, where x is the number of years. So if I want to figure out how much is after 6 years, I can go to num and look it up how much it is after 6 years right here. So it's $95,713. Okay, if I want to calculate how long it takes to double, you're probably not going to find it exactly in the table. Unless you want a whole number of years, you can look it up in the table. If you want to find exactly, because this could happen in the middle of the year, let's just graph. So doubling, it would go to 160,000. Okay. Now I'm going to need to see up to 160,000. So I'm going to go 200,000 on the y value. The maximum y value, 200,000. Okay, and x in this case is number of years, so it's probably going to happen before 20 years, so I'll just leave it like that. Oh, it's actually after 20 years, so it's over here somewhere. You can go to menu, function, intersection, so it is 23.2 years. Okay, how long does it take to double? We can write down this to show work. We're basically solving this equation to the power of 4x, or n actually for number of years, and this gives us n is about 23.2 years. Okay, we can even show a sketch. Sketches always look the same. It's just a horizontal line crossing an exponential function, so it's 23.2 comma 160,000. You can also do this on an app on your calculator. So let's check out this app. It's called the Finance app. Alright, apps, finance, down here. And you click on num, I believe, and then you can get this menu right here. Alright, yeah, so everything's listed right here. The number of interest periods. So in this case, let's do this here. In this case, we have the number of compounded periods is 24. 6 years, but it's compounded quarterly, so that's 6 times 4. You can even write 6 times 4 here, but that is simply 24. And the interest rate is obviously 3. Present value. Now here's the thing, present value, I'm going to put that in as a negative. Okay, so you can put it as negative or positive, but these two values should be opposite, the present value and future value, because that's the way the app works. But you need to pick what your notation is, and we're going to go with negative if you're paying in money, like investing it, and future value is what you're taking out at the end, so you're receiving it. We're going to call those numbers positive. Okay, so this is negative. The present value was 8,080. 1, 2, 3, 80,000. Payments, we can leave that 0 for now. This is for if you have, if you're paying into it every month. Okay. This is payments per year. It is compounded quarterly, so that's the k value. K equals 4. Always check end, and this here is calculated by itself. What we're calculating here is the future value. So you can just click on it and then click on solve, and it'll give you the future value. So as you can see, the app gives you the same value as we got with the formula. And we can also use the answer part B. We want the future value to be 160,000, so we can just type that in. 160,000. Oops. Let me try that again. Future value 160,000 is positive because it's money that you get. Yeah, and this is all the same. In this case, it's quarterly. You want to solve for n the number of years it takes to reach 160,000. So you just click on the n cell, and then you click on solve, and it gives you actually gives you the number of compounding periods. So that's 92.77. That is the number of quarters. So you can actually do 92.77 divided by 4. And where can I do that? Let's escape here. 92.77 divided by 4. And it gives you the same answer as we got the other way, which is 23.2.